Hello everyone, I am Cyrus Raj. My enrollment number is E20CSE236. Currently, I am a third year BTech student in Bennett University. Today I want to discuss you about Moore and Mealy machines, which comes under the subject Automata Theory and Computability. So before moving to Moore and Mealy machine, let's discuss what is automata. Automata is a theoretical branch of computer science and mathematics which mainly deals with the logic of computation with respect to simple machines, referred to as automata. Automata enable scientists to understand how machines compute their functions and solve problems. The main motivation behind developing automata theory was to develop methods to describe and analyze the dynamic behavior of discrete systems. Automata originated from the word automaton, which is closely related to automation. So what are the basic terminologies of theory of computation? So let's take understand the basic terminologies which are important and frequently used in the theory of computation. So the first is symbol. A symbol, also known as character, is the smallest building block which can be any alphabet, letter or picture. Like we can take the example like A, B, C, 01. So what is alphabet? Alphabet are a set of symbols which are always finite. Third one is string. A string is a finite sequence of symbols from some alphabet. A string is generally denoted as W and the length of the string is denoted as mod W. Moving on to the next slide. Let's discuss about Moore machine. Moore machine is a finite state machine whose output values are determined only by its current state. This is in contrast to a Mealy machine whose output values are defined both by its current state and by the values of its input. Like other finite state machines, in Moore machines, the input typically influences the next state. Thus, the input may indirectly influence subsequent output. So, the Moore machine is named after Edward F. Moore, who presented the concept in 1956. So we can see the output symbol at a given time depends only on the present state of the machine, and it is described by six tuples, which are Q stands for finite set of sets, Q naught stands for initial set of machines, sigma stands for finite set of symbols, O denotes output alphabet, delta denotes transition functions. You can see like Q cross sigma implies Q, and lambda is the output function. Moving on to the next slide. So what is Mealy machine? So Mealy machine is a finite state machine and its output symbols depends upon the present input symbol and present state of machine. The output is represented with each input symbol for each state represented by slash, and it is also described by six tuples which are same in Mealy and Moore machine. So moving on to the next slide. So let's take an example and understand it, the conversion of Moore to Mealy machine. So it is example. So here the it is x comma 0 where x is the state and 0 is the output. So let's understand, if we take b as the input in x, so it will be in the same state and its output will be 0. If we take input in x in a, then it will go to y state and its output will be 0. Similarly, if we take input a in y, it will be in the same state and its output will be 0. And if we take input b in state y, then it will go to z state and its output will be 1. Similarly, you can see for z state also. So in z state, if we take input as a, it will go to state y and its output will be 0. And if we take input as 1 in z state, it will go to state b, in state x and its output will be 0. So moving on to the next slide. So this tab will make you understand more properly that here x is the state here. So if we take input a in x, then it will go to y state, and similarly if we take input as b in x, it will go to x. It will remain at x state, and its output will be z. So you can refer for this for more proper, better understanding. So moving on to the next slide. So here we can see the formation of state transition table of Mealey machine. So before explaining you this, let's discuss what are the differences between Moore and Mealey machine. So Moore machine output depends only upon the present state, whereas in Mealey machine the output depends on present state as well as on present input. In Moore machine also places its output on the transition, whereas in Mealy machine places its output on the transition. More states are required in Moore machine, whereas less number of states are required in Mealy machine. There is less hardware requirement for circuit implementation in Moore machine, whereas there is more hardware requirement for circuit implementation in Mealy machine. They react slower to inputs, which means one clock cycle later in Moore machine, and in Mealy machine they react faster to input. And Moore machine is easy to design, and whereas Mealy machine is difficult to design. So let's understand the formation of state transition table for Mealy machine. So here X is the initial state. So if we take the input A here, so it will go to state Y and its output is written as 0. Similarly here, if we take input B in X, it will go to Y state and its output will be 0. Similarly, you can check for Y and Z. So moving on to the next slide. So how to format Mealy machine into from Moore to Mealy machine. So here is the transition table. So we can see that in Moore machine the input is inside the inside the state, but here we can see that the input is out. So if we take input B in X state, so its output will be 0. Similarly, if we take input in state X, its output will be 0 and it will go to Y state. Similarly, if we take input in state Y, it will go to state, it will remain at state Y and its output will be 0. Similarly, you can see it for state Z also. If we take input A in state Z, its output will be 0 and it will go to state Y. Similarly, if we take input B in state Z, it will go to state X but its output will be 0. So moving on to the next slide. So here we will learn how in step by step to convert Mealy to Moore machine so that you can understand it more properly and in a systemized manner. So in step 1, for each state Qi, calculate the number of different outputs that are available in the transition table of the Mealy machine. And in step 2, copy state Qi. If all the outputs of Qi are the same, break Qi into end states as Qin, and if it has a n distinct output where n equal to 0, 1, 2 and so on. In step 3, if the output of initial state is 0, insert a new initial state at the starting which gives one output. So coming on to the next slide. So let's take example to understand the conversion better for the Mealy machine. So if we take input A in state Q1, its output will be 1 and it will go to Q2. Similarly, if we take input B in Q1, it will again go to state Q2 and its output will be 0. Similarly, if we take input A and B simultaneously in Q2, then it will go to state Q4 and its output will be 1. So it can have the same output for different inputs. So for let's take in Q4. So if we take input A in Q4, then it will go to state Q3 and its output will be 0. So similarly in Q3, if we take input B, then its output will be 1, but it will remain in same state. Similarly, you can do it for Q4. So moving on to the next slide. So here is a step by step so that you can understand better the conversion of Mealy to Moore. So for state Q1, there is only one incident edge with output 0. So we don't need to split the state in Moore machine. For state Q2, there is two incident edge with output 0 and 1. So we will split this state into two states Q2 0. state with output 0 and Q21 with output 1. So for state Q3, there is two incident edge with output 0 and 1. So we will split this state into two states, Q30 whose state with output 0 and Q31 state with output 1. For state Q4, there is only one incident edge with output 0, so we don't need to split this state in Moore machine. Here we can understand in tabular form the more better way. Here it is a present state which is defined as Q1, Q2, Q3 and Q4, and these are divided into two columns. So if we take input A in Q1, it will go to Q1, again it will remain at Q1 and its output will be 1. Similarly, if we take input A in Q2, it will go to Q4 state and its output will be 1. Like if we take input A in Q3, it will go to Qt and its output will be 1. In Q4, if we take input A, then it will go to Q3 and its output will be 0. Similarly, you can see the same for the state for input B. If we take input B in Q1, its output will be 0 and it will go to Q2 state. Similarly, like you can check all other like that. So moving on to the next slide. So the next slide we will learn about transition table for Mooney machine, what it will look like. So if we take input A in Q1, it will go to Q1. And if we take input A, which values is 1, it will go to Q2. Here A has different values, so it will go to different states. If we take input A, which is 0 in Q20 state, then it will go to Q4 state. And similarly, its output you can see here. So one thing is clear, like for A equal to 0 and A equal to 1, if we take input in Q1, its output is same. So we can similarly check for other like if we take input A equal to 0 in Q20 state, then it will go to Q4. And if we take input A equal to 1 in Q20 state, it will go to Q4 and its output will be 0. So similarly, if we take A equal to 0 input in Q21 state, then it will not go to any state. So if something is not going to any state, then we can define it by phi. But it doesn't mean that it doesn't have output. It may have output. So we can see here like it has output 1. Similarly, if we see like for Q30, if we take A equal to 0 input, it will go to Q21. And if A equal to 1, we take input in Q30, it will go to Q35. It will go to and its output will be 0. So in Q31, if we take A equal to 0 input, it will go to Q21 state and its output is 1. And if we take Q31 A equal to 1 input, so it will go to Q31 and its output will be 1. So similarly, you can check for Q4. So let's move on to next part. So here is the transition diagram for motion machine and what it will look like. So like I explained earlier, if we take input A in Q1, then its output will be 1, but it will be in the same state. And if we take input B in Q1, its output will be 1, but it will go to Q20 state. So similarly, we can see here the main difference is like in Mealey machine for Mooney machine that the output is inside the state, and here in Mealey machine the output is not inside the state. So we can see and learn by the following. So you can learn by the following. So thank you. I hope I am able to make you understand what is Moore machine, what is Mealy machine, the conversion of Mealy to Moore machine and Mealy to Moore machine. I have also given all the steps included in tabular form and in with diagram also, so that you can understand properly. I hope I am able to make you understand. Thank you.